Alright, so let's take a look at number 3. I've already included the starter points or reference points, the A, the H, and the K, as you can see on the right side right here. The A comes from this part of the equation. The H is the value that we see up here in the exponent, and the K is this number here that's added or subtracted from the function. Okay. The reference points are -1, 1 over b. Since b is 4, you get 1 over 4. 0, 1, and then 1, b. In this case, the base is 4. So we know that how A affects the function is that it's a vertical compression, and being negative, there's going to be a reflection over the x-axis. So how we're going to demonstrate that in our graph is by multiplying the y values by -1/2. So we get -1. Oops, let me change it back to 1. So -1. 1/4 times -1/2 is -1/8. And then the next point, 1 times -1/2 is -1/2. And then the third point, 4 times -1/2 is -2. Okay? The next transformations are the H and the K. We apply the H and the K. So that means that we're going to add 2 to all the X's and 3 to all the Y's. So I usually write it up here. Let me use a different color. So this is going to be +2 and +3. Okay? So 2 minus 1 for X is 1. 3 minus 1/8 is 2 7/8. For the next point, 2 plus 0 is 2, and then 3 minus 1/2 is 2 1/2. Okay, and for the third point, 2 plus 1 is 3, and 3 minus 2 is 1. So that gives us the 3 points that we're going to be graphing. So that's these 3 right here. They're going to graph. But remember, the first thing we add on our graph is, or that we draw on our graph, is the asymptote. And when it's exponential, like I said in class, exponential functions have horizontal asymptotes. And where we get that number, that's basically our K value. Okay? So this means that our horizontal asymptote is going to be at y equals 3. So up here, y equals 3. Okay, and then we plot the 3 points, 1 and 2 and 7/8. So about here. Oops, it's not showing very well. And then 2, 2 1/2, and then 3, 1. Okay, so there's the 3 points. So we just draw a smooth curve going through those points as best you can. And there it is. They also want you to state the domain, the range, the asymptote, so this is going to have a horizontal asymptote, and the end behavior. Okay, so for the domain, we know the domain of all exponential functions is all reals, and we could see it from the graph. You notice that as you go to the left, the arrow means it goes to the left forever, and then this goes to the right forever. I know it's going down, but it's still moving towards the right forever. So the domain is all reals. For the range, we look at the graph. Notice how the points do not cross this line right here. So they're from just below that line, forever going down. So how you write that would be all y such that y is less than 3. That's if you write it in set notation. You could write it in interval notation, which would be from 3 to negative, so from -infinity to 3. That would be how you write it with intervals. Horizontal asymptote, y equals 3. And end behavior, we want to describe what happens at the end. So in other words, what happens here and what happens here at the ends. Okay, so you say as x goes to negative infinity, y goes to 3. In other words, as the graph moves towards the left, it's moving up towards 3. So it goes towards 3. As x goes to positive infinity, or just infinity, y goes down. So it goes to negative. Okay, so that's this problem. Alright, so here we have number 4. Again, just like on the last problem, I am showing you the A, H, and K right here. The A comes from this part of the equation. The H comes from the exponent, so x, the formula is x minus h, so that means h is negative 1. And the K, K4, comes from this part of the equation. Okay, our starter points, because this is a decay function, the base is 1/3. Remember, 1 over b would be 1 over 1/3, which becomes 3. 0, 1, and then 1b, the base is 1/3. So the first transformation we apply is the a. A being 2 means that we're going to multiply the y's by 2. So then that gives you negative 1, 6, 0, 2, and 1. 1/3 times 2 is 2/3. Okay, the next group of transformations we'll do together, h and k, so that means that we're going to add negative 1 to the x's. I'll put negative 1 right there, I know it's kind of crowded. And then we're going to add 4 to the y's. So negative 1 minus 1 is negative 2. 6 plus 4 is 10. Negative 1 plus 0 is negative 1. 4 plus 2 is 6. Negative 1 plus 1 is 0. 4 plus 2/3 is 4 and 2/3. Okay? So we draw our x and y axis. Okay, so I drew the x and y axis. Notice I put the x-axis towards the bottom because my y values are rather large, 10, 6, and then 4 and 2/3. So the first thing I'm going to draw is the horizontal asymptote, which is at y equals 4 and y4, because that's what the k value is right here. So at y equals 4, there's a horizontal asymptote. Then you go ahead and plot the 3 points that are on your list, negative 2, 10. So that's about here. Blue. So negative 2, 10. And then negative 1, 6. Negative 1, 6. And 0, 4, and 2/3. So again, that's approximately right there. Connect the 3 points. And there you go. There's the graph. So now we're going to answer domain, range, horizontal asymptote, and I'll put EB for end behaviors. Okay? So domain, again, all reals. Range, the y values are all above the the line y equals 4, right? So you're going to say all y such that y is greater than 4. Horizontal asymptote, y equals 4. End behavior, again, remember we're describing what's happening here and what's happening as we go to the right and as we go to the left. So we're going to say as x goes to the left, negative infinity, the y goes up, positive infinity. As x goes to the right, positive infinity, y goes towards 4. And that's it for that one.